All right. Another thing that we talk about is the number of terms. That's literally just how many terms are connected with addition or subtraction. I don't even really know how to define it. It's just, that is the definition. But I'll write number of terms connected with addition. Oops, if I could write the word connected, that would be good. I was trying to connect my ends, but it just looks like an M. Connected with addition or subtraction. So if I were to look at this, I would say, well, how many terms are there? Well, how many things are connected? You have 1, 2, 3, 4. So that would be a polynomial with 4 terms. And then the last thing I kind of talk about just with the general setup, it's called standard form. And when we are writing polynomials, we basically always try to write it in standard form. Once again, if not, then everyone writes it their own way and it's kind of confusing. We like one set way to write things. And standard form is when you kind of rearrange your polynomial and you want it to start with the highest exponent and then go down in order to the lowest. So you're going to write in order from highest to lowest exponent. Once again, we have that, so all of our answers always look the same. If not, things would kind of be out of order, they'd be kind of weird. So it kind of keeps everything on the same page. That's just some quick little things, because once again, polynomials is kind of a new concept to us. Now, another thing we do with polynomials is we name them. Oh, we give them little names. That's so precious. So I'm going to put up a chart in a second. There's actually 2 charts. We name them based on 2 things. We name them based on the degree and then the number of terms. So I kind of brought those up first because that's something we're going to need. I just don't want to rush to erase, so I'll give you another second. So we basically are going to have like 2 little charts that we're working off of. One based on the polynomial's degree, one based on the number of terms, and I'll show you how we kind of name them from there. I'll give you another few seconds. I guess I could fit it. I just hate writing super small, so I'll just erase. All right, and then we'll look at a bunch of examples, because as of right now, I'm just kind of giving you some definitions. So naming polynomials. We're going to start with the name based on the degree. So there's going to be 2 of these little charts. They're just kind of quick. So we have degree. In the name. Or I'll do an example. No, I'll do the name. Sorry, I'm just deciding how I want to set this up. And I'll just put a quick example just so you can see what I'm talking about. So something can have a degree of 0. Hey, can anyone remind me if the degree is 0, and I say something like, that just means x to the 0. Hey, oh my gosh, it's almost like exponents are related to this. If something's raised to the 0 power, it equals
0, 1.
Oh, it equals 1, come on. It equals 1. So basically it ends up just equaling a number. We call that a constant. So if something's just a number, we call that a constant. So an example, like if I said 3x to the 0, that just equals 3, right? Or if I just said 12, we say that's a constant. We say that the degree is 0, because technically there is an x to the 0 there, we just don't really write it. So a degree of 0. A degree of 1, this is going to sound familiar to you, because if we have an equation or an expression like 5x plus 2, hey, that kind of looks like mx plus b, right? When you just have an x or an x to the first, we call that linear. So we're kind of familiar with that. we're used to looking at equations. This is just an expression for now. But if you just have something to the x to the first, it's a linear, it will be a line. 2, you may have heard this word before. It's called quadratic. So you have something like 2x squared plus 5x plus 3, something like that. If your highest exponent is 2, we call that quadratic. And lucky for us, our next chapter is called quadratic. So we do a big old exciting stuff with that. And I'll leave this up for a few minutes when I'm done as well. 3 is called cubic. That sounds familiar. If you cube something, you raise it to the 3rd power. So you can get like 7x cubed plus 11. So it doesn't necessarily, you could have as many terms as you want. And then you're probably saying, like, how many names are there? There's a few more. 4th power we call quartic. That kind of makes sense. Quartic, 4. So once again, any polynomial, it doesn't matter how many terms there are, as long as the highest exponent is 4. We have one more special name, and that's 5. It's called quintic. You've heard of quintuplets, you have 5 of them. I can't think of anything else that starts with quin. I don't know. That's kind of your starting for 5. So anything that's, I'm getting lazy here, is 8x to the 5th. I'm getting lazy writing my examples. Now you're probably saying, well, okay, this is annoying because we have so many words. After that, there's no special names. So if you get to 6 or 7 or 8 or 92, you just say 6th degree, 7th degree, 8th degree. So I'll just kind of do that down. I'm just making up random ones, but the main thing is that your highest exponent is 6. So we have those first 5, and we're familiar with some of those words anyways. Like linear and cubic, those sound kind of familiar to us. Some of them you could probably just figure out if I told you the word. But those are the words we use to start to name. Now we have a whole other chart, sorry. We'll write them quick and then I'll give you a few minutes. Based on the number of terms. Oh my gosh, whole other chart, are you joking me, Mr. Sherman? These ones, there's not as many names. But just kind of bear with me for a second. You just need to kind of write them down once and then you can refer back to it. Just want to make sure I'm actually on board, and I am. Now, over here, we could have a degree of 0. You can't have 0 terms, though. That just means you have nothing. So you can't have 0 terms. You can have 1 term. And we call the general names a polynomial. If you have 1 term, we call that a monomial. Anything that starts with mono represents 1. So a monomial just represents 1 term. So 1 term would be like 7x to the 5th. There you go. There's nothing else connected with addition or subtraction. I kind of like these ones. They make sense. Number 2, or 2 terms, that's called a binomial, right? Bi means 2, bicycle, all those fun words. So that just means 2 things are connected with addition or subtraction. I like addition for some reason. There's some subtraction in there. Hey, can anyone guess what 3 is? A trinomial, yeah. That just means there's 3 terms. After that, there's really no special names. So if I say there's 4 terms, we literally just say it's a polynomial with 4 terms. So this is, I feel like I keep using the same. No, I'll just use 7. That's a polynomial with 4 terms. So 5 would be a polynomial with 5 terms, or 6 terms, or 7 terms, or 92 terms, or whatever. So I'm going to leave that up for a second. I know that was kind of a lot to write, sorry. This is one of those things we just got to write it once so that we can refer to it. So I will leave that up for you for another minute or two before I move on to the next thing. So the next thing is we're just gonna actually use those words just to get used to them. How do we actually name? But I'll give you like 2 more minutes.
How about them?
Yeah.
Yeah.
Let me take a look. So next up, if I say name something, like, what does the name even look like? I have these 2 charts now, like, what do I do with them? So we'll get used to that. We'll also get used to writing things in standard form, just making sure that they're in the right order. So we're not actually like doing much, we're just kind of moving stuff around and naming them. And then after that, we'll just look at some addition, subtraction. We'll keep it light on this intro day. And then over the course of the next week or 2, we'll do things like if we add or subtract today, we'll multiply, and then we'll do some dividing, which when we divide polynomials, it's a special name called factoring. So we'll do a lot of factoring this term. And that will be our next few weeks. And to tell you the truth, this chapter is kind of quick. Because it kind of leads into the next chapter. We use a lot of these things. So we'll probably like be done with this before vacation, which is kind of delightful. Oh yeah, we'll definitely be done before vacation. So and then we'll come back and just basically like do quadratics the rest of the year. Quadratics is one of my favorites as well. Because I won't all be together as like a nice little family. We can do things like quadratics and then take a walk. Or quadratics and then we pass the pig. It will be easier when everyone's here, so that kind of, it allows us to, I don't know, like be humans again, right? For me to just not talk to a screen and have people stare at me all day. Hopefully we can get our personalities back. I'm hoping. That's why I'm going into this with a positive attitude, like maybe people will talk to me again. Oh my gosh, what a life it will be. Okay, more than the one person that talks. Thank you, you do talk to me, right? But you're the one. Literally the one out of all of my classes. It's pretty, most of my classes are pretty torturous.
That's depressing.
I know, isn't it? I know. Try being me for a living, you know? I just sit here and I just talk to myself like 99% of the time. So I'm gonna say, I'll kind of leave those out for a second, but I will erase in a second. We're gonna write in standard form. I'm just gonna do one over here just so I can refer to the and name. Yeah, that's my life, guys. Just me talking to the screen, talking out no one. One of these days. Okay, so we'll just start kind of basic. Well, you can't make these too crazy. It's you give you a polynomial. If I say write in standard form, if it's out of order, we're just going to put it from highest exponent to lowest. And then we'll base our name off of those 2 charts. So we'll kind of go over how to use those. So if I gave you something like 5x plus 12x to the 3rd minus 7. And I said, hey, first step, can we write this in standard form? Literally, you just look at the exponents, right? So technically 5x, that's to the 1st. This is to the 3rd. This we call a constant because it's just by itself. There's no x. So technically it's x to the 0. So first thing we have to do is rearrange it. So we're going to put the 12x to the 3rd as the first term because that has the highest exponent. Sometimes I just kind of cross them off as I go. Then the next highest exponent would be 5x to the 1st. Since it's positive, I put a plus. And then last would be that minus 7. Okay. So that's in standard form. And then we say, well, we got to name it. So you really have to use both charts. So you kind of, you go in this order, that's why I did them this way. So the first thing we name it on is the degree, and the degree is the highest exponent. So since the degree is 3, we call this a cubic. Cubic is like an adjective, it's just describing something. What is it describing? So you see how many terms I have. I have 1, 2, 3 terms being connected with addition or subtraction. 3 terms we call a trinomial. So we would call this a cubic trinomial. There you go, fun stuff. So that's kind of the idea, okay? Can we rearrange? Yeah, we can we're not even like doing math here, we're just like putting things in order, nothing too crazy. And then can we use our charts just to name it? So you always name it, you do the degree word first, and then the number of terms word second. So we call that a cubic trinomial. Don't say trinomial cubic, that doesn't make sense, just English-wise. So I am gonna erase my charts. Does anyone still need them before I erase them? I tried to give you a few extra minutes. Just so I can use that squat on the board. So let's do like one or two together, one or two together, one or two on your own. And then we'll just look at adding and subtracting quick. Those are pretty easy though. Literally you just add and subtract, so nothing too crazy. Number 2. Let's do 11 minus 6x to the 4th plus 3x minus 2x squared. Okay, we should be good. So if I said standard form, I'd say, okay, I can kind of rearrange these and just put them in order. So the order is we're looking at the exponents. So just make sure we call that a constant, just a regular number. We say this is to the 4th, this is to the 1st, this is to the 2nd. Okay, so I find my highest exponent. Just make sure when you're rearranging, you take the entire term, which means you take the base with the exponent, you take the coefficient of that, which is the number in front, and the sign stays with it. So if I was rearranging this, I would say negative 6x to the 4th, my first term. The next in order would be minus 2x squared, so I'm just going down in order. And then plus 3x to the 1st, and then plus 11, because that's a positive 11. So we got a nice little polynomial in standard form. And then once again, I wouldn't think you would have those memorized because you learned them 3 minutes ago. So use your charts. If my highest exponent is 4, the degree is 4, we call that a quartic. And then I look and I say, well, how many terms are connected? 1, 2, 3, 4 terms. Means that's a quartic polynomial with 4 terms. I just wrote W, 4 terms. So that, my friends, is how you would name it. So I'm going to have you guys try one. This isn't hopefully too terrible, but I just want to see, can you kind of do it on your own? So can you write this polynomial in standard form? And then can you name it? Another few seconds, so it shouldn't take too long, hopefully. You know, it's not too work intense. It's just like, okay, what do I do? You do it, you're done. Nothing too crazy. Sorry, I'm just trying to do that sentence here. Okay, guys, let's rearrange this. How exciting. Look at your exponents. You got, technically that's a 1, right? A 3, a 2. I need to go from highest to lowest, so this is my highest exponent. Whatever's in front of it stays with it. So that would be negative x cubed plus x squared plus x. Or you could say x to the first. And so nothing too crazy, just moving things around. And then it looks nice. You know, everything's going down in order. We all have the same answer. And then this would be called a cubic. Oh, another cubic trinomial. How exciting. At the current moment, does anyone have a question with writing something in standard form or with naming something? Wasn't that just great, guys? So proud of you. Let's do a little addition. We can add, and then we'll do a little subtraction. Literally, I'll show you 2 problems, 1 addition, 1 subtraction. And then, excuse me, we'll try 1 or 2, and that will be today. I'll try to keep my numbers. So that was number 3. So I'll call this number 4. And then number 4, I'm going to add. But with the addition, I'm going to make sure my answer is in standard form. And I'm going to name it. Because, you know, you might as well get, we have those things, you might as well get used to them because we see them a lot, no matter what type of problem you have. So here's what an addition problem looks like. 3 plus 6x squared plus I'll write it and I'll kind of move because I know I'm semi in the way here. So the one thing I want to point out, this is a polynomial with 4 terms. That's a trinomial. That's okay. You can still add them. So they don't need to be the same size. They can be whatever they want to be. Our main goal is literally we're just combining like terms. So things are alike when their base and their exponent is the same. So if I have an x to the third, I can combine that with an x to the third. If I have an x squared, you can combine that with an x squared. But you can't combine an x third with an x squared. So that's the main idea of this. So I pretty much just go through, I just start with my first term. I find anything that I can combine with it, and then I just see what I get. So I'm an underliner. So I like to organize myself. So I say, ooh, this has an x to the third. And this has an x to the third. Let's add them. So when you add, you just add the numbers in front. The exponent stays the same. So you never change an exponent with addition. So 2x to the third plus 5x to the third is 7x to the third. Because I literally just do 2 plus 5. So I just kind of keep going. Next, I see an x squared. But I don't see an x squared anywhere else. Okay, so 6x squared plus nothing is just 6x squared. So don't say like, oh, there's nothing to combine it with, like it crops up. No. You got 6x squared and there's nothing to combine it with, it just stays as that in the answer. And then I have 5x. And I want to add it, oh, I see an x over here, just minus 10x. So I'm going to use the coefficients. 5 plus negative 10 will just give me negative 5x. And last but not least, I have a constant and a constant, so just my regular numbers. And 1 plus 11 gives me 12. And once again, if it's positive, you put a plus because you need to separate your terms. That gives you your answer because there's nothing else to combine. Everything has different exponents. And then we name it. I'm loving cubics today. I don't know why. Third power is cubic. And then there's 4 terms, so we just say a polynomial. I'm getting lazy, so I'm just going to write poly with 4 terms. That's the idea. So main goal, we've combined like terms a million times this year. That's all you're doing with addition and subtraction, combining like terms. Just make sure when you write your answer, it is in standard form from highest exponent to lowest, and then you're naming it. So let's look at a subtraction, and then you guys are going to try to, and then we'll be done. Number 5. Sorry, let me write it, and then I'll get out of your way. I'm getting lazy, so I'm just going to write standard form. Name. But let me actually write the problem first before I Let's do 6x squared minus 5 minus 2x squared minus 7x minus 1. I'll do that for a second. All right, so we think in our head, well, I can subtract, like, whatever. Mr. Sherman, like, this is easy. Adding, subtracting, we've done this, been doing this for a while. You just need to be careful with polynomials. Once again, we have a binomial, we're subtracting a trinomial, that's fine, not a problem. Here is the issue that you run into sometimes with subtraction, so I'm going to show you the first step that I usually do to kind of take care of this issue. One, you just need to make sure when you're subtracting a negative that you're adding. So like little things like that, sometimes you're rushing and you forget about. The other issue is we don't have any just regular x's here, but we do here. So with subtraction, it gets a little funky if I'm subtracting from nothing. So here's what I usually do to kind of take care of all the sign issues. I take this minus sign, or that, yeah, the minus sign, and I distribute it in. What that's gonna do is just take care of all my signs for me. I don't need to worry about the double negatives or subtracting from nothing and all this stuff. That gives me negative 2x squared. A negative times a negative is a positive 7x. And once again, a double negative is plus 1. So then I basically just bring down that first polynomial. And now I'm going to combine like terms, like I just did with the addition problem. X squareds, let's combine them. I have 6x squared, and now I can see that I have minus, because I'm subtracting, 2x squared, that will give me 4x squared, right? So I'm never changing the exponents, I'm just dealing with the numbers in front. To save myself some time, I like to just do it in standard form so I don't need to rewrite it. So I remind myself, if x squared is my first term, are there any x's? And there are, right here. Now I took care of my signs already, so I'm good. And I just say, well, if I have a 7x and I have nothing to combine it with, it's just going to stay as plus 7x. And last but not least, my constants, my numbers. I have a negative 5 here, plus 1. That would give me minus 4. And now there's nothing else to combine. So I like to do that step where if I see subtraction, I just distribute it. It takes care of my signs for me, and then I can just kind of add everything. If you're not doing that, just be very careful with your signs and subtraction. That's where you can get yourself into a little trouble if you're rushing or not paying attention. And we want to name this bad boy an exponent of 2 we call quadratic. And 3 terms, we call that a trinomial. So that is a quadratic trinomial. What a beauty. So basically, as a wrap-up, I'm just going to have you add 1 and subtract 1 and kind of see how you feel. And then tomorrow we'll do a little multiplying and dividing or factoring. Do you guys, because now I really never know what you guys do because last year was so messed up. Have you guys talked about greatest common factor before, GCF?
Yes.
Okay,
Yeah.
so it sounds familiar, but I'm sorry, I don't know if you did it with polynomials, but like the idea of like having something in common and dividing it out, we'll talk about that tomorrow as well. And then we'll just keep chugging along, just having fun, like always. That's the name of this game in this class. And then, yeah, that's it. No assessments this week. I'll put up that grade once I can actually get into Power School. So hopefully that's by the end of the day at this point. Because it's been a few hours here. We've been waiting for it to pick up. And then once again, Wednesday, we're going to kind of we'll take it easy. Maybe do a game or something. I don't need to, I always like Algebra 1. Algebra 1 is my favorite class, but I especially like you this year. No, because you're so nice. And because you're my only Algebra 1 class, so I can kind of just do whatever. I'm not when you have multiple classes, you're we got to keep them on the same page. Got to stay in the same spot. Like my other classes are like that. This one, it's we can just do whatever we want. Yeah. Because I don't have anyone else to compare you to, so just me hanging out. But that lends us to Wednesdays not having to do work, so that's just we'll have a little game or something. I don't know. And we'll do that survey about our seating chart, so I can start to work on that. All right, so here's your wrap up. For everything, I'm just gonna write standard form and we're gonna name it. Just to kind of get used to those concepts because they're things that just always pop up. So that's why we start with it because it's something we'll see for the rest of the chapter. But for one, can you add? I'm making this really easy for you guys. That one should be pretty easy. Just two binomials, come on. Nothing tricky. And number two, subtract. Alright, so those are the two you're trying. Once again, you know the difference because one has a plus and one has a minus. So I can put them in the same section. You're just kind of looking, well, what am I doing? I know what I'm doing because there's a sign there that tells me what I'm doing. Be careful with the subtraction and your signs. That's the big thing. Addition's easy, you just add. You don't have to worry about anything. But subtraction, it can kind of mess you up if your signs are a little funky. So pay attention. See if you can do it. And then once again, if you can't, we'll just practice more. That's the beauty of school. They just learn all the time, guys. So I'll give you the next few minutes. For you guys. And hopefully it seems as though Power School's don't mind working. It's going really slow, but I'll do my best. I have study next period to put those grades in. If not, I'll do it after school, so I should be updated at some point today. All right, we're just gonna start to go over those quick because they shouldn't hopefully take too long. I just want to make sure I have enough time. We only have about 4 minutes left. But number one, I'm loving because there's like nothing to say. It's literally okay. This has an x. This has an x. Add them. 2x plus 3x is 5x. We have a 6 plus negative 12. That would give me minus 6. That would be my final answer. There's nothing else I can do. And we would call that a linear binomial. Once again, the highest exponent is 1 because you have x, which is x to the first. Just be careful with that. And then I go here and I say, all right, I have subtraction. So I still to this day, like I'm an algebra teacher, and if I was doing this on my own, because you know I love to do math all the time, I would take this minus sign and I would subtract it in. I would distribute it in. I would get negative x cubed minus 6x squared plus 12. That kind of takes care of my signs for me. I'll bring down that first polynomial. And now I'll combine things. And I like to combine things so they're in standard form. So I just start where the highest exponent is. My highest exponent is right here. And there's nothing to combine with it. So it would be negative x cubed. My next highest exponent would be x squared, which is here and here. So I can combine those. 5 minus 6 gives me negative 1x squared. My next exponent in order would just be x to the first, which is here, nothing to combine with it, so that would be minus 3x. And last but not least, we have our constants here and here, and that would give me plus 11. So you can notice I had two trinomials, I end up with a polynomial with 4 terms, so that doesn't really have an effect on your answer, so just be careful. And we would call this a cubic polynomial with 4 terms. 99% of this is just staying organized. So if you're not organized, do something to do, like you can see I always do the little underlines. I make sure my signs are okay. And then I just try to write things in that correct order, just so I don't have to reread it a million times. But that's the idea of those 2 problems. So when we come in tomorrow,